Hello everyone. Today we'll talk about the solution to the problem remove subfolders from the file system. It's very easy to guess that the final solution to this problem will probably involve a tree, because we have all the standard makings of a tree problem. We have a set of strings, so we do not care about the order of the strings, so we can represent them in any way that we want. In particular, we can represent them as a tree. And also we're interested in some strings being prefixes of other strings, which is very easy to see in a tree, because if we have one string inserted and then we had another string inserted, then the point at which they diverge is the point at which their longest common prefix ends. So we'll be using a tree. Of course, typically I tend to implement a tree as a separate class, but in this case I tried something different. You can see this is line 4. I'm not sure if by imposing the constraints that I impose on myself, which are unnecessary, it's possible to write it shorter. So this will be a bit of a functional programming challenge for you. But anyway, let's get back to the solution. One thing that we can do is to, for convenience, sort all our paths in increasing order of length, because that guarantees to us that whenever we see a subfolder of some already existing folder, then that already existing folder has to be shorter than its subfolder, so we have a guarantee that it was already inserted to our tree. And we'll be having just our tree represented as essentially a dictionary. So for every new path, we'll be starting at the root of our tree. We'll be splitting our path into separate directories based on slash. And we'll be also marking whenever we see an end of a full path with this artificial character. In my case, it's the $sign. And at every step, if the $sign is in the current node of the tree, that means that we have already inserted in our tree a path that ends at this point exactly, which means that our current path, since it reached that point, is a prefix, or that previous path is a prefix of the current path. So we shouldn't do anything else. In fact, we don't have to insert the rest of our current path, because we're guaranteed that this path will be removed from the final result list. And of course, everything that has this new path as a prefix already has its prefix as a prefix. So we don't have to do anything. Otherwise, we just descend on our tree one level deeper based on the transition of the current directory. So based on that string. And of course, at the end, we use for else clause to make sure that this only executes if we haven't used break, this line 11 break. We can append to the result our current path, because that path did not have a prefix before. And at the end, we just return the result. So this is a very concise way of writing it, because we don't use a separate tree data structure, a separate tree class, as I tend to do. And also this is a single pass. While we're constructing the tree, we're also calculating the result. And now the thing which happens on line 4, I'm wondering if it's possible to do it in any better way. I guess it's a functional programming challenge maybe. Because if we use a separate class to represent our tree, then we get for free this recursive structure where a tree has children and those children are all also trees. But how to do it without using a separate class? Well, if our tree is just a normal dictionary, then we don't have to really do anything. Whenever we want to go to a child and that child doesn't already exist, we just first create a new dictionary, because our tree is a dictionary, for that child, and then we descend down that path. And of course, to avoid being forced, when using a dictionary, to create the value for a given transition for a given key, it's typical to use a default dictionary. Default dict. Because default dict is just a wraparound dictionary, such that when you try to access a key that doesn't exist, it creates a default value for that key and returns you that value. Okay, so that's very simple. Our tree should be a default dictionary of tree. So if the tree, well, and you see the problem that's happening here, because we don't know what a tree is. This is an infinitely recursive structure that uses itself, because previously we didn't have that problem because it was a dictionary and we can create a new dictionary whenever we want to descend. But in this case, we want to have this infinite recursion of a tree being a default dictionary of exactly this, so exactly a default dictionary of this thing. So it's default dicts all the way down, and it'll probably be easier to do it in multiple lines, but I was thinking about how to do it in a single line. And finally I settled on something like this. So when it comes to thinking about it, you of course don't have to think about it. You can implement it as a class, you can implement it in any other way, or you can just implement it as a normal dict, and you will have here in lines 10 to 12, just write, before you use char of directory, you have to see if directory is in char, and if it is not in char, then you just write char of directory equals an empty dict. So that will probably be the easiest solution, but I'm finding it hard to believe that there is no easier way to write it in a single line than what I've did on line 4, and if you want to think about it, then it's your chance to challenge yourself when it comes to functional programming. By the way, when it comes to syntax, if you're not very familiar, for instance, here we have this function, anonymous function, which self-applies its argument to itself. So it takes as an argument a function and invokes that function with itself as an argument. And we immediately, after creating this lambda, we immediately invoke it on this argument. And this argument is, of course, a function that takes one parameter, and then this is a function which takes 0 parameters. So if you want to parse through what is written here, then feel free to do so. If you can come up with a better way of creating this self-recursive default dict, a default dict of infinitely nested default dicts, then feel free to let me know. But yeah, this was so funny that I decided just to include it to scare some people, because thinking about things like this happens in functional programming, and I guess it's not for everyone.